A very important characteristic of a believable, realistic human eye is the sharp highlights we see in between the eyeball and the eyelid. This encircles the entire opening and it covers the caruncle and gives the eye a distinctive wet appearance, which breathes a lot of life into a rendered eyeball. And this reflection comes from the eye meniscus. If we switch over to the googly googs and search eye meniscus, we can find some additional information about what this is. But for me personally, the simpler explanation comes from test tube meniscus, which is the one random fact I remember from science class. And that's when you put a liquid in a test tube, how the water in a test tube, the liquid kind of creeps up on the interior of the container and forms a curved transition. So that's what's happening to our eye. The eyeball is wet, and as it touches the eyelid, we get that curved transition. And practically this results in these sharp reflections. And that's what we're going to create next. And this part is kind of fun to make, I think. We already have all the geometry we need from the head mesh. We're just going to extract the faces around the eyelid. So I'm going to duplicate our head mesh, right click so it doesn't translate anywhere. I'm going to rename this eye-meniscus. And this is now the third piece of eyeball geometry, so I might as well create a new collection within the head collection and call it eyes. And then move our meniscus there, as well as IL and IL001, which I should rename to be I.R. And we'll unhide the eyeballs. And for our eye meniscus, we don't need the multi-res. We also don't need any of the shape keys. So to collapse the stack, I'll simply, in object mode, add new shape from mix and start removing all shape keys starting at the top of the list, with that combination being the last one, and this serves to collapse our stack. Now I can tab into edit mode, face select mode, and specifically choose the edge loop that defines the thickness of our eyelid. And then also the caruncle. So C to circle select, grab the caruncle, Control I, invert selection, and X, delete faces. All right, so then from here, there's a few extra edges in the corner that I want to get rid of. It just doesn't need to be that tightly packed. And then I'll select the interior border edge, fill it with F, and then I to inset a new edge loop. This is what will attach to the eyeball, while the rest of it attaches to the eyelid. Now there's a little bit of a fix I need to make here. Often when you use inset, really tight edges will kind of flip, so I need to S-1 and undo that because we had proportional editing on. S-1. There we go. And then finally back to solid view, we can delete that interior face we created. Also, we can, in edge mode, select everything, Control E, and clear seams. We don't need any UV seams for this. Now we'll leave local view, and I want to snap our geometry to our eyeball. We'll have to go probably edge by edge, so let's do the interior first. I hit 5, so we're in orthographic. Best for snapping generally. I need to enable snapping, face snapping particularly, and we don't want to project onto itself. Let's try that again. G and left click to snap. There we go. And then we'll do the outside edge as well. Might have to go in manually to this edge and kind of pull it there. Then we'll snap the caruncle. And then finally this interior edge. Or it's kind of in the middle. There we go. All right, now everything should be snapped to the surface in edit mode. And we're ready to start adding modifiers like the shrink wrap modifier, which will essentially suction our meniscus to the surface of our mesh. And first to do that, I need to add a subsurface modifier because we need a lot more geometry for an accurate shrink wrap to the higher frequency details of our sculpture. So let's, we'll make it 3 levels in viewport and in render. I think that should be enough. And before I add the shrink wrap modifiers, I'm going to go ahead and make our viewport a little more distinguishable by adding a color to our meniscus object. We'll make it red and switch over to viewport object shading mode. There we go. Now we can see if we have penetration or not. So after subdivision surface, we can add a shrink wrap modifier, and we want to target I.L. Now immediately we have a problem because we only want certain vertices snapping to the eyeball and we want other vertices snapping to the eyelid. So I need to tab into edit mode and define these verts with a vertex group. All right, so we'll go to our object data. I'll remove the old shrink vertex group, add a new one and call it shrink underscore eyeball. And this will only take our interior verts with it. So we'll select those and then assign at a weight of 1, which is full influence. And then Control I to invert the selection and Shift Alt, click that second edge loop to deselect it. Create a new vertex group, shrink underscore eyelid. We'll add full weight there. And then for our interior edge, I'm going to add that at 0.5 weight to each vertex group. So it kind of splits the difference. All right. And now we can go back to object mode. We can leave local view and adjust our modifier, the shrink wrap modifier, to only use the shrink eyeball vertex group. And then we can duplicate this and choose our head object as the target and the vertex group to eyelid. Okay, so now we've got them shrinking to the proper targets. However, I want to make this meniscus just ever so slightly hover off of the surface. If it intersects the geometry, we get a weird artifact with the material, which has kind of been driving me nuts recently. So the best solution that I found is just to hover it ever so slightly off the surface. We'll change the offset of both shrink wraps to -0.0001. Okay, so that just ever so slightly gives us a gap there. We'll do the same thing to the bottom one, -0.0001. And we're still getting some penetration, actually pretty bad. Let's see, maybe I got my shrink wrap settings wrong. Okay, so instead of on surface, let's try outside on both of them. Yeah, okay. And then I need to invert the offset to be positive. Yeah, okay. Okay, that's looking a lot better. Still a couple areas that need some fixing. Let's see here. So we'll take these verts, make sure that they're snapped to the surface. There we go. All right, just move them around, and then up here at the top, it looks like we might need to kind of slide. Oops, let's turn off snapping. I'm gonna slide up. There we go. I still want the crease to be pretty tight at the top. See, that maybe is a little too broad. So let me undo that and then try again. Okay. I think that's going to work out well, just barely hovering above the surface. And now to put it on the other side, I think I'll need to duplicate it. I don't think a mirror will work. We can try it. But yeah, I think the asymmetry in the sculpture is not going to let us do that. So instead of a mirror, I need to do it manually. So I'll rename this one to imeniscus.l. And then I'll use Shift-D this time. I don't know if I can trust that the linked data will be enough. So I'll duplicate it, rename it to imeniscus.r. And then in edit mode, let's see. Actually, before I go to edit mode, Shift-S, snap the cursor to selection, because that's at the center of the horizon of symmetry. Tab into edit mode, select everything, SX -1. But of course I need to do that with my 3D cursor as the pivot. Let's try it again, SX -1. And then double check the face orientation. I need to flip those, so Shift N. And then I should just have to change the snapping, the shrink wrap target of the first one to be I.R. Okay, this one might need a little bit of extra help. So I'll turn off face orientation. And yeah, just on the top side, might try and kind of move this down with a small fall off. Maybe not with proportional fall off. Let's see, maybe just snap manually. If we turn on our shrink wrap modifiers in edit mode, I want to use median point for the pivot. This can be a little bit finicky, as you can tell, but it's very much worth it to get it right. Okay, I think this will work. There we go. Okay, so with both meniscuses modeled, it's time for the material. So if we go to our shader editor, let's remove the skin from both of them. We'll add a new material. We'll call it eye meniscus. Control L and make sure we're linking the materials. All right, now we can go to rendered view, turn off our overlays. And first thing I'll try is with the provided principled BSDF, we'll make sure our color value is all the way up at 1. Let's take our roughness down to 0 and then transmission up to 1. And now we can see in the reflections that we are starting to get that sharp reflection in the corner, but using actual transmission isn't going to be ideal here because it's just a flat plane. There's no thickness to the material to get refractions. In a very practical sense, all I want is that sharp reflection. So to simplify this, I will remove the principled BSDF and we're going to add a shader transparent BSDF. And then I'm going to mix it with a shader glossy BSDF. So here I'll change the roughness to 0 and add a shader mix shader node. And let's mix those two. Shift control clicking to see the 50-50 mix. And it's way too reflective. We need to favor transparent much more. So let's go to like 0.1 and that's looking much better. However, you may notice that there is a darkening underneath the surface of our eye meniscus, and that's because the glossy BSDF is casting a shadow. So next, I'm going to use a trick with the input light path node to make sure it doesn't cast a shadow. I don't want any extra darkening in the crevice here. And so if we just use this transparent BSDF again in a mix and use the is shadow ray as a factor, then this transparent BSDF in slot 2 says that for shadows being cast, we're using the transparent, i.e. we are having no shadows. And so now we don't see that darkening anymore. And we're definitely getting much more of a wet eyeball feel to our eye setup. And so that's essentially what we're after, but I can refine it a little bit more. Let's try rotating our environment around. Let's try 90 degrees. I want to see a little bit more illumination on the eyeballs so we can see that nice sharp shadow. However, I do think my meniscus is reaching a little bit too far into the eyeball. So it's just a little too broad. I want to tighten the influence of the reflections. And I can do that with simple vertex colors. So let's go to solid viewport. Make sure our eye meniscus is selected. Probably should have added this before I duplicated it. Anyway, not a big deal. So we'll go to our vertex colors and I will remove SSS depth. We don't need that anymore. Just residual from when it was the head object. And I'm going to call this simply mask. And I need to do the same thing to the other side or to the other meniscus. So remove it, call it mask, call the new one mask. And then I'm going to tab into edit mode and select the outside edge loop and the inside edge loop. Tab to object mode and then vertex paint and enable vertex masking and choose a black color, Shift K, and we'll be able to use this as a factor to narrow down the reflections only to where the white part of the vertex colors is. All right, we'll do the same thing quickly to the other side. And now we can look at render view again, source those vertex colors in our shader editor with Shift A input vertex colors mask. Make sure it's working on both sides. Excellent. And then if we add a converter color ramp, I can have a little bit more control over this mask, either make the blacks a little bit darker or the whites. Now, instead of a white value, I want to make it the factor we established here. So we liked 0.1, so I'll switch that value to 0.1. Use that as the factor of the first mix shader. And then we should see a tighter effect on the reflections. It should be a little more concentrated, not such a broad meniscus. And let's see, I'm going to bring up the black a little bit more. Specifically here, I want to see if I can eliminate that corner by bringing up the black. There we go. It's starting to diminish. Maybe change the interpolation to ease. Okay, I think we're in a pretty good spot. How's it look on the other side? Let's see. I don't really see anything on the other side. Oh, okay. Just needed to switch around the lighting. See, I think that's looking pretty good. I think we're ready for an initial test render. All right, so here I've got no eye meniscus, switch to slot 2. And let's see what it looks like with the eye meniscus. Okay, let's see the full resolution. For a second, I didn't think we were getting any on the left eye, but it is there, just it's not being hit directly by the light. Whereas the right eye is getting that. I think the reflections are a little too strong, so I can dial down the amount of glossy mix. But if we look at the before, I forgot I changed the light a little bit. But definitely more lively with these reflections involved. And so yeah, I'm going to dial down the reflections. And the only other component I like to add is a little bit of noisy bump so that our reflections are not perfectly straight and crisp. If we look at our reference, there tends to be just a little bit of bumpiness, wobbliness involved. If it's too straight and too perfect, it, I don't know, kind of looks stylized or sort of cartoony. This sort of thing where it's kind of broken up is much more common. All right, so we'll go back to the material and select our eye meniscus. And I'm going to add a texture, noise texture, Control T to add a texture coordinate node, and we'll use object coordinates and then Shift Control click so we can see that effect, and increase the detail to 10 and perhaps the roughness to like 0.6, and then plug this into a vector bump node as the height input, and then this will go into our reflection, our glossy BSDF in the normal slot. But let's just Shift Control click on the bump. All right, so that's the effect I'm going for, but nowhere near that strong. So let's try 0.05. We want it to be, much more subtle than that. And there we go. We've kind of wobbled out the reflections. So I'll need to do a full render to know for sure if that's the right value, but I think we're on the right track. And then the other thing is to dial down the amount of reflections. We were at 0.1. So let's go to, I don't know, like maybe half that, 0.05. Yeah, I think that looks a little tighter, a little more realistic. So we'll do another render in slot 3 for comparison. Okay, let's see that. Definitely more wobbly. Alt J, this is before. So a perfect reflection. Now it's broken up. I think that looks like an improvement. The strength of the reflection is still fairly high. So, I don't know. I could possibly dial that down too. I'll keep that in mind. Remember, I like to sort of finish the first phase and then let potential changes kind of marinate in my mind. So that's going to be one for the eyes. But at this point, I'm happy enough to see multiple lighting scenarios to give me further insight on how this setup is working. So I'll do that quickly and cycle through them when they're done. Okay, let's shuffle through these lighting scenarios. Okay, wow, this one, basically no reflections show up in the right eye. I'm not sure if there's anything I can do about that other than just to shift the lighting. It shows up in the left eye, but if this were my final render, that would be a valid criticism against it being realistic. You almost always see that meniscus reflection show up a little bit. So, I don't know, it's just something to keep in mind. Here it looks pretty good with the front key light, kind of like a snapshot on a camera or a flash on a camera. But what it does reveal to me, it's possible for the reflection to show a gap in between the eye and the lid. Ideally, this will be concentrated right there, which means that perhaps my meniscus geometry is too far away from snapping to that geometry. So that's something I'll keep in mind. Again, I don't plan on doing the final render from this type of lighting, but data collection, that's what these tests are all about. Here with my studio setup, I think it looks really good, though perhaps the reflections are a bit too hot or intense, I mean. So this is more evidence that I should probably dial down the amount of reflections. But yeah, the way that the reflections play in the caruncle are much more realistic now. Overall, I'm very happy with the addition of the eye meniscus. And then this is that forest lighting, which looks really good. Looks nice and wet, alive in terms of a believable eye. And so I'm really happy with the meniscus in its first iteration. It's probably something I'll tweak along the way like everything else, but I definitely feel that it's a big step towards realism. So in the next lesson, we will add eyelashes.